Good afternoon, everyone. My name is Diaconu Maxim, and together with Professor Cristian Popescu and Professor Mihai Bogdan Petrișor, we have together written the paper entitled Energy Efficiency Index, a Literature Perspective. Since energy efficiency has an important role in achieving sustainable development, its accurate assessment is of considerable significance and necessity. However, despite the fact that there are various studies that have tried to define the concept and also to measure it, there is no general agreement about an energy efficiency index. Considering this aspect, the purpose of the present paper is to analyze the existing literature on the topic in order to assess the robustness of the different index models and to highlight the gaps that exist in the current academic discourse. Various studies reveal both common features and also differences in how energy efficiency index are designed. For example, in terms of normalization, most indices normalize energy usage to some measure of output, service, or usage, such as floor area, buildings, number of occupants, production output, or exergy produced. This, of course, allows comparisons. Also, in terms of operational versus asset rating, some indices are based on modeled or theoretical baseline. Others use measured real-world data, often with corrections for external factors. Also, there are differences in terms of multidimensional or composite indices. The energy efficiency indexes are sometimes composite or multi-factor, including technical efficiency, operational management, occupancy, behavior, quality of life, and so on. Also, we have noticed some sector specificity differences. The structure of the index tends to depend heavily on the sector, such as building versus industry versus technology systems versus integrated energy systems. Each of them has its own relevant variables, constraints, and reference measures. Also, in terms of benchmarking and policy use, indices are often used for benchmarking performance, for setting policy goals, or evaluating progress over time. We have also noticed some challenges in terms of data quality and availability. Many studies showed inconsistent, missing, low-quality data, making comparisons or normalization difficult. Also, in terms of defining appropriate reference baseline, this also was a challenge. The external factors such as climate, occupancy, usage patterns need to be accounted for, otherwise indices may mislead. Also, in terms of trade-offs, making an index simple versus making it accurate and comprehensive. Therefore, more detailed indices are harder to maintain. Considering all these aspects, we may say that there is no single standardized way to construct an energy efficiency index. Instead, energy efficiency indexes are highly sector-specific, tailored to different environments such as buildings, industrial processes, data centers, or urban areas. Almost energy efficiency indexes involve normalizing energy consumption to a relevant unit such as square meters for buildings, number of occupants or users served, production output in manufacturing, computation load in tax systems. So this allows for apples-to-apples comparisons across different entities or time periods. Also, studies highlight that a key distinction between asset-based energy efficiency indexes and operational efficiency indexes. Asset-based energy efficiency indexes are estimates based on standardized condition or design specialties. Meanwhile, the operational efficiency indexes are based on actual measured energy usage in real-world conditions. Both are useful, but operational efficiency indexes offer more practical insights into real efficiency performance and user behavior. Also, some studies show that failing to account for how spaces or systems are actually used can skew efficiency ratings. Incorporating occupancy data or usage metrics leads to more accurate and meaningful energy efficiency indexes. Also, there are newer models that propose multi-factor energy efficiency indexes which integrate technical system performance, management quality, environmental conditions, behavioral aspects, and also energy. These offer a more complete picture of efficiency but are harder to implement and to interpret. I hope you found my paper interesting, so thank you very much for your attention.